All right, so as we're getting ready to dive in to start to analyze circuits, there are a couple laws that we use that really govern circuit analysis, and these are known as Kirchhoff's laws. Actually, there's two of them, two main ones that we focus on. One of them we already covered, and that was the junction law, and this determines or this tells us stuff about current in the circuit. And then there's Kirchhoff's loop law, and this will help us understand the voltage drops across the different circuit elements. So that's what we're going to talk about, just basics today before we get into actual circuits and analyzing those circuits. So first, we already talked about it, is Kirchhoff's junction law. And this just means that if there's current going in, so there's current going in, here's I1, current going in, and here we have a branch. It can either go to the right to some circuit elements or it can go straight to other circuit elements. So this current that goes in to the circuit has to equal the current going out, which means that essentially the current going in is I1 has to equal current 2 and current 3. The sum of those two. And this is very simple if we think about, again, about like a stream of water. If a stream of water splits into two different streams of water, the total amount of water has to stay the same. Well, it's the exact same concept, except now we're talking about the current in terms of electrons. So the electrons going in has to equal the electrons coming out. And this is just a conservation of charge. The other main law is thinking about what's happening with the voltage drop. Now, if I think of like an object in terms of its gravitational potential energy, it depends only on its position, not the path that it took to get that position. Well, the same concept is true with electric potential. So the battery is giving me electric potential energy. Now, as the charged particle goes around this loop here, it's going to lose some of its electric potential energy across its resistors, in this case, and then it'll come back to the bottom with 0 electric potential energy. So what does that mean? If I have 1.5 volts here, it goes and it drops the voltage across resistor 1, and it drops some voltage across resistor 2. And the sum of those two voltage drops has to equal my 1.5 volts. And by the time it gets back to the battery at the bottom, it's 0 volts. So the net change in the electric potential around any loop must be 0. So if I start here, if I start at point A and I go to point B, I'm gaining electric potential energy. But as I go across the resistors to part C, I didn't lose any there, but part D I lost some electric potential energy, and part E I lost some electric potential energy. So sometimes it's helpful to look at it in terms of a graph. At point A, I have nothing. The battery between A and B gains electric potential energy. This is like me climbing up a hill. Now, as I'm going back down the hill, I'm losing some of that potential energy. In this case, I'm losing voltage. So from C to D, which is resistor R1, I'm losing some voltage, and from D to E, which is resistor R2, I'm losing some voltage. And those two voltage drops, voltage 1 and voltage 2, have to equal the voltage of the battery. So as we're going around the circuit, the voltage drops have to equal the voltage drop of the battery so that the total potential change, the electric potential around the entire circuit, must be 0. This is like going up the hill and coming back down. So here is a different version of looking at that. For a loop, all that means is we pick one point and we go around that circuit until we get back to that point. Now this is just some basic resistors put in here, whatever you want to think of it, but they could be resistors, they could be batteries. But as I add up all my voltage drops, it has to be 0. That is Kirchhoff's loop law. So the sum of all the voltage drops has to equal 0. So here's a quick check. We have just a piece of a circuit, and we have these different resistors here. But the question is, I have 2.5 amps here, I have 1.5 amps here. What has to be the current going through this 200 ohm resistor? Well, for that, I can use Kirchhoff's junction law. If I have 2.5 amps coming in, 1.5 amps went down here, that leaves 1 amp of current going across the other resistor. And this alone is enough to tell us a lot of information when we get into the actual analysis of circuits. So this is what we'll use to help us understand anytime we have a junction in a circuit. And this only happens in what we call parallel circuits. Parallel circuits are when we have a junction. When we get into series circuits, different story, we'll talk about that. There is no split, so no matter what, the current is the same throughout a series circuit. So here's a quick little example. There's a current of 1 amp in the following circuit, right? There's no junctions, so there has to be 1 amp going through the entire circuit. All right? So what's the resistance of this unknown element here? So Kirchhoff's junction law, we don't need to worry about because there is no junction. So instead, I can use Ohm's law to help us understand this. I have 1 amp of current and 3 ohms of 3 ohms of resistance. So Ohm's law says 1 amp times 3 ohms, that's 3 volts that are being dropped across this resistor right here. 1 amp times 2.5 ohms is going to be 2.5 volts across here. So now Kirchhoff's loop law states that if I were to start here and go across my entire circuit and come back here, the voltage drop has to be 0. So I start with 0. I gain 9 volts. I have positive 9 volts from the battery. I lose 3 volts from the 3 ohm resistor. I lose 2.5 volts from the 2.5 ohm resistor. So how much voltage drop has to be right there? Well, I take 9 minus 3, that's 6, minus 2.5, well, that's 5.5, that's 3.5 volts is remaining, and that has to be dropped across this last resistor. So Kirchhoff's loop law states that I start at 0, right here, I gain 9 volts, I lose 3 volts, I lose 2.5 volts, I lose 3.5 volts, and I'm back at 0. So that's Kirchhoff's loop law for determining what that voltage drop is. Now, the question though is what's the resistance? I can again use Ohm's law. 3.5 volts divided by my 1 amp, that means this is a 3.5 ohm resistor. And that's the basics with circuit analysis. So we'll go through with these two concepts, these 2 or 3 main concepts, right? We got Kirchhoff's loop law, we have Kirchhoff's junction law, and then we have Ohm's law. And those 3 are enough to analyze the types of circuits that we're going to be looking at. So in the next section, we'll be taking a look at the difference between series and parallel circuits and then learning how to analyze that. And we'll be doing those in the next 3 sections.